Hello, today I'm doing an unboxing of the Analog Devices 633 analog multiplier chip. This, my friends, is a chip that I have always wanted to buy. Ever since I discovered it, I don't know, 10, 20, 30 years ago. It is the simplest chip that you can imagine, other than what chip that simply adds two values together. This multiplies two values together. The thing is, it is shockingly expensive, especially for what it does. This is an 8-pin dip, for crying out loud. Hang on, let's open it up. Yes, I'm in my bathroom sink. The light is good. Don't judge. Here we go. I managed to buy two of these by saving up my pennies. Yes, for one little 8-pin dip, you pay $17 for the privilege of multiplying two analog signals together. Now, I know there are other ways to do this. You can use OTAs, but honestly, I don't have the time to learn how to use OTAs right now. I looked at a couple circuits and it's like not too bad, but I'm already designing like a complicated thing. And it takes me weeks and months to design things analog anyway. So first I'm going to ground myself to the bathroom sink before I touch this mighty little chip. Now, these chips used to be $10 a piece, which was a lot, back in 2000. And I used to dream of making a distortion circuit that was built out of these things. See, what you can do is, if you recall the Taylor series for making polynomials. So it is possible, as you may recall with the Taylor series, to convert any signal, such as a line, into any other signal, such as one with a nice exponential ramp. And so what I was thinking is that you would have a signal go in with X, and then a couple multipliers would provide the X squared, and then another multiplier would provide the X cubed and the X fourth, all the way up to, I don't know, maybe like 15 or 19 or 20 or something like that, X to the question mark. And then you would have a whole bunch of pots that would add up all of these. And you would have a beautiful 100% analog, zero delay way to make a wavetable circuit, a wave shaper circuit for basically any distortion characteristic that you might want. Only problem is, at $10 a pop, that gets exceedingly expensive. Do you like my summer? Drawing this to the camera is kind of crazy. So if I were to have 20 stages of these $10 chips, that would have been $200 just to make a wave shaper. And never mind that they now cost $17 a piece. And the thing is, I don't know why it's so hard to make like one little chip like this costs so much. And the thing is, it's not even that accurate, okay? It boasts an error of 2%, okay? So 2% is about 1/50th, which is somewhere between 1/32nd and 1/64th. Why do I bother with those? Because that's 2 to the -5th or 2 to the -6th, which means that you only get about 5 or 6 bits of accuracy and the rest is noise. So why does a chip like this cost so much? Is it because it has an insanely wide bandwidth? I mean, maybe the military is like hooked on using these for like extremely high powered radars. I don't know. By the way, while I'm complaining about the cost, I just want to point out that on the Analog Devices website, they bill this as the low-cost analog multiplier. So if this is the low-cost one, I don't even want to know what the high-cost one is like. Anyway, I'm not making this wave shaping distortion circuit tonight. I'm making something else that's kind of still secret and I can't talk about because it's got to do with the newest electric eels. But rest assured that there is certainly some analog multiplying going on. So check in a few weeks to see what I come up with. And then we'll find out if the $17 is well spent or not.